Hello students, welcome back to Year 8 Maths. For this lesson, I want to review what we have talked about for the first 4 weeks. So it's more like a revision or a consolidation of what you should know from the first 4 weeks. But before we go on, I need you to be prepared. I need you to have something to write with. I need you to bring your maths book and also a calculator. So please make sure you have these 3 things before we keep going. Alright, okay, so what have we talked about for the first 4 weeks? The term that you have heard over and over again will be index. What does index mean? What's another word for index? Well, you can call it the power. Or if you want to be really fancy, it's called a exponent. But what does this tell us? What does the index tell us? Well, the index or the power tells us how many times you multiply that number by itself. So for example, if I say 2 to the power of 3, this 3 tells me I've got 2 times 2 times 2. So 2 multiplied by itself 3 times. So this is what we call the index or the power. Alright? So we know this little 3 is called the index. What do we call this 2? The base. Alright? So the 2 is the base. So in another word, the power or the index tells me how many times the base is multiplied by itself. Alright. So you would have also heard the expression called index form. You would have, if you have done the worksheets, that's a question asking you to express your answer in index form. What does that mean? Well, this is what we call the index form. Because this form has an index, right? But you would have also heard to express your answer in expanded form. What does that mean? What does expand mean? Expand means we make something bigger, right? So basically what he's saying is, what does 2 to the power of 3 mean? Well, it means 2 times 2 times 2. These 2 expressions, they mean exactly the same thing. But it just looks expanded. Right, so this is what we call the expanded form. Okay, and this is what we call the index form. Alright, the index form has got an index. Expanded form is asking you, okay, what does that really mean? And also, you would have seen a question asking you for the basic numeral. What does that mean? Well, what he's asking is, what's 2 times 2 times 2? 2 times 2 is 4, 4 times 2 is 8. So this is what we call the basic numeral. Alright? So if you are going to express this whole thing with a number, okay, that's what the basic numeral means. These 3, they mean exactly the same thing. Alright? So let's try a little exercise before we go on. In your book, I want you to have 3 columns. The first column is called the index form. Then we are going to have expanded form. And then we are going to have basic numeral. Alright? So, I'm just going to give you one of the 3, then you are going to fill out the rest for me. Alright? So let's have 3 to the power of 3. Okay? And then I'm going to have 5 times 5 times 5 times 5. Okay? Then I'm going to have 16. Okay? So you are going to try these 3 questions for me. Pause the video and have a go. Alright, let's quickly check our answers. 3 to the power of 3, expanded form would be, obviously it's 3 times 3 times 3. 3 times 3 is 9, 9 times 3 is 27, so the basic numeral would be 27. Second question, I gave you the expanded form. I want you to write your answer in index form. Very simple, the base would be 5. How many times did we multiply 5 by itself? 4 times, 5 to the power of 4. And what's the basic numeral? 5 times 5, 25 times 5, 125 times 5, 625. Alright, so this time, the last one is slightly a little bit trickier, 16. How do we express 16 in index form or in expanded form? What is 16? Well, 16 is 8 times 2. And what's 8? 8 is 2 times 4. And what's 4? 2 times 2. So really, 16 is just 2 times 2 times 2 times 2, right? 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. That's the expanded form. Index form would be 2 to the power of 4. Very simple. Alright, so let's move on. Alright, so let's look at the important part of this unit, the index laws. You should have seen these laws before. If you haven't, if this is the first time you have heard of index laws, I need you to stop the video and go back to lessons from week 1 to week 4. Alright? What I'm doing is, I want to summarize what we have learned. Okay? So, the first index law will put A. What I want you to do is, open up a new page with your heading index laws. I want you to include 3 columns for me. The first one is number, second one is the index law, and the third one is an example. Okay? So the first index law, what does the first index law tell us? What is it? It would be if I have a to the power of m times a to the power of n. Remember, the key is same base, a to the power of m multiplied by a to the power of n. Remember, you can see the base has to be the same. What does that equal to? That equals to a m plus n. I'm not going to use this lesson to explain to you why. If you want to know why, again, go back to previous lessons. Alright, so this is what you need to remember. A to the power of m times a to the power of n. Remember, the keys is a times. It's not a plus. If this one and this one, you don't add the power. Alright? Only if you're multiplying numbers in index form with the same base, then you can add the power. Let's do an example. If I've got 5 to the power of 3 times 5 to the power of 2, what would the answer be? Well, do they have the same base? Yes, they do. Am I timesing? Yes, I am. What can I do? Simply add the power. Keep the same base. 5, 3 plus 2, which is 5 to the power of 5. As simple as this. Let's move on to our second index law. What does our second index law tell us? What if we are dividing? Alright? This time we're dividing numbers of variables with the same base in index form. So, if I have a to the power of m divided by a to the power of n, okay, remember when we have the line, the fraction line in between, or if you want to be really fancy, you call this the vinculum. This is essentially a division sign. Okay, so this thing is saying a to the power of m divided by a to the power of n. Okay, they mean exactly the same thing. Alright, same base, dividing, what do you do with the power? We minus them. So that equals to a m take n. Alright? Very simple. So let's do an example. If I've got x to the power of 10 divided by x to the power of 3, what would that equal to? Alright? Check. Do I have the same base? Yes, I do. Am I dividing? Alright, yes, I am. I can just simply minus the 3 from the 10. So x 10 take 3 equals to x to the power of 7. That's how you use the second index law. Okay. What about the third index law? The third index law is a very super simple one. It's the one that everyone shouldn't have any problem with. That's the power of 0. What happens when you raise something to the power of 0? What does that become? Becomes 1. So if you've got a number, a variable, and you raise it to the power of 0, it's just going to become 1. If you want to know why, go back to your lesson in previous weeks. Here, I need you to remember this rule. A to the power of 0 equals to 1. So my example can be, I can have 9,999,999. But if I raise it to the power of 0, it will still equal to 1. Okay? Third index law. The fourth index law is, what if we are raising a power to a power? Okay? So for example, if I've got a, and I raise a to the power of m, then I'm going to raise it to the power of n. What happens? So I've got a already raised to the power of m, then I'm raising this whole thing to the power of n. Okay? What do? You simply, in this case, you are going to multiply the powers together. A m times n, or mn. Alright? Mn, please don't make the mistake. Mn doesn't mean m plus n. Mn means m times n. As I said many times, mathematicians are lazy. If we don't have to write something, we don't write them. Mn means m times n. Okay? So let's do an example. So if we have 7 to the power of 3, and then I raise it to the power of 2, what does that equal to? Okay, I'm raising a power, and then I'm raising it to another power. I just multiply the powers together. 7, 3 times 2, 7 to the power of 6. Okay, so these are the 4 index laws. And then you will find a lot of questions that we deal with combinations of these laws. You might find questions that you might have to use 3 of these or all of these. So here, I'm going to help you to solve a few questions based on these 4 index laws. All right, let's have a look at these 2 examples. Question 1, I want you to write down the question and then you're going to work through these with me. I've got 5a to the power of 3 times 2a to the power of 4. What does 5a to the power of 3 mean? What's implied? Implied meaning what's assumed? What do we know? 5a to the power of 3 means 5 times a to the power of 3. Right? Times 2. 2a to the power of 4 means 2 times a to the power of 4. Alright? So here, we can group the similar items together. Right? What can I multiply this 5 with? 5 is a number, it's a constant. I can multiply the 5 with the 2. Right, 5 times 2 is just 10. Remember the times table, 5 times 2 is 10. What can I group this a to the power of 3 with? A to the power of 4, right? Remember, when we are multiplying things, we can rearrange the order. This whole thing just is the same as 5 times 2 times a to the power of 3 times a to the power of 4. Remember, when we're timesing, 2 times 3 is the same as 3 times 2. We can shift the order. So, 5 times 2 will give me 10. A to the power of 3 times a to the power of 4 will give me Which index law do we use? The first one, right? Same base, you add the powers. So it becomes 10 times a to the power 3 plus 4, right? Which we can simplify a bit more. I don't want to write that much. I don't need to write this multiply sign. 10a, 3 plus 4 is 7. So your answer should be 10a to the power of 7. Let's look at the second one. It looks like a really long question, but if you think about it, it's not really that bad. 7m is the same as 7 times m times 4 times n squared times m cubed. M to the power of 3, you can call it m cubed, times 2 times n times p. Next, I can group similar things together. Right? I can group the numbers or the constants together. So, what can I multiply the 7 with? I can multiply the 7 with the 4 and the 2. So 7 times 4 is, what's 7 times 4? 28. Right? 28 times 2, 56. Okay? If you can't do that, use your calculator. Then next, let's look at the m's. What can I group the m's with? I've got an m here. I've got m to the power of 3. What does m by itself mean? If I have to write m in index form, m is the same as m to the power of, you should know that, m to the power of 1. M to the power of 1 is m. If you raise anything to the power of 1, it becomes itself. Okay, so if I have a million to the power of 1, it's a million. M to the power of 1 is m. So this one is actually m to the power of 1. We don't write it because mathematicians are lazy. We don't have to write things that we don't need to, but we know m to the power of 1 is just m. So we can group this m and this m together, which means that becomes m, same base. If I'm timesing, I add the power 1 plus 3. Let's look at what else. I have got the n's, so I've got n to the power of 2 times n. N is just n to the power of 1. Alright? So that becomes n to the power of 2 plus 1. Am I missing something? Yes, I am. I'm missing this loner at the back. We still have to multiply by the p, even though it has got no friends, it's got no similar items. We still have to multiply. So p, clean this up a little bit. So your answer would become 56, and 1 plus 3 is to the power of 4, and 2 plus 1 is 3, p. So that's your answer. Okay? This is the expanded form. This is the index form. Okay? I'm going to put a few questions on the slide for you to do next. Alright, so let's go through another 3 questions. Again, I want you to write down these questions and then you're going to work through each step with me. I've got d to the power of 12 divided by d to the power of 4. Alright, I want you to solve it for me. I want you to simplify that for me. What can we do? Which index law do we use? We're going to use the second index law, right? The second index law tells us if we have the same base, if they're in index form, and if I'm dividing. Right? Then I can just simply multiply, minus the powers. So in this case, d to the power of 12 take 4, which is d to the power of 8. This one is very simple. It's just a direct application of the second index law. Now let's look at question 2. It looks slightly scarier, but when we really think about it, it's not really that bad. Okay, so to make it easier for me to say, to work out, I always like to write it out like fractions. I can replace this division sign with a line, with the vinculum. 36a to the power 5, they're going to go upstairs. Then I'm going to chuck these downstairs. 9a to the power of 2. Now, it looks much more doable because we can group the numbers together and we can group the variables together. Let's look at 36. What can I do with the 36? Well, I'm actually dividing 36 by 9, right? I can group 36 and 9 together. 36 divided by 9 is just 4. And I can group these two together. A to the power 5 divided by a to the power 2. We can use the second index law, right? A to the power 5, take 2, right? Same base, dividing, minus the powers. Clean this up, 4a to the power of 3. That's it. See how cool this is? We can express all that just by 4a to the power 3. They mean exactly the same thing. Alright, look at this. Again, this one looks even more scarier, but if we break them down step by step, it's not really that bad. What we can see is, I'm always timesing and dividing. We remember, when we're timesing and dividing, we don't care about the order. We can change the order. We're not adding or minusing anything. That's great. Which means, I can simply operate with the numbers, and I can operate with the variables. Right? So let's deal with the numbers first. I've got 7 times 4, and then over 2, meaning I'm dividing by 2. So really, I've got 7 multiplied by 4 divided by 2. 7 multiplied by 4, 28 divided by 2 is 14. So all the numbers I can replace by the 14. Now let's look at the t's.
Attention students, Montana Preston to student services, Montana Preston to student services.
So now we've got t to the power of 3. Alright? And then we're multiplying it by t to the power 4. If I'm multiplying with the same base, what can we do to simplify it? We can use the first index law. And then we are dividing. Is it the same base? Yes, it is. I can use the second index law. Alright, so let's see how cool this is. I can multiply these two together. I can add the power. 3 plus 4. And now I'm dividing, which means I'm going to minus the power. Alright? So next, we just need to clean this up. 14, t3 plus 4 is 7, take 5, 2. So your answer is 14 t to the power of 2. So this whole thing and this guy, so simple, but they're exactly the same. Okay? So I'm going to put a few questions up for you to do. Have a go before we move on. Okay. So let's step it up a bit more. This time we're going to include the third index law into our equations. Alright, let's look at question 1. I've got 39 times 48 times t to the power of 0. Okay? So, the key point is I've got these set of brackets. So what I'm saying is everything inside the bracket is raised to the power of 0. So what would my answer be? What does the third index law say? If you raise anything to the power of 0, it becomes 1. So this whole chunk just becomes 1. Very simple. You'll be very happy if you see questions like that in an exam. Now let's look at number 2. 19b to the power of 5, c to the power of 0. Does that all become 1? have a think about it. Does it become 1? Let's have a think about it. This power of 0, does it apply to this whole thing? Or does it only apply to the C? Do you see brackets? There's no bracket, which means this 0, this power of 0 only applies to this C. Alright? So, 19 is not going to become 1. Your b to the power of 5 won't become 1. Only this bit is going to become 1. Okay, so 19 will stay the same, b to the power of 5 will still stay the same, c to the power of 0 becomes multiplied by 1. So your answer would just be 19b to the power of 5. So please make sure you don't make the mistake of automatically assuming whenever you c to the power of 0, you're going to say, oh yeah, it's going to be 1. It won't. If in this case it won't, because it will only be this bit becoming 1, but I'm still timesing 1 by whatever's stuck in front of it. But in this case, because I'm saying everything is raised to the power of 0, so that's why this whole thing will become 1. Let's look at question 3. Okay, 6m to the power of 3 times 11m to the power of 14 divided by 3m to the power of 10 times 2m to the power of 7. So in this case, we're going to use all of the first 3 index laws. Alright, so let's see if we can sort out what's upstairs first. Remember, we can group the numbers together and we can group the variables together. So I can group the 6 and the 11, because 6m to the power of 3 is just 6 times m to the power of 3, which means there's everything on top is just a big multiplication. So I can multiply the 6 by 11, which gives me 66, right? And I can group the m to the power of 3 by multiplying that with m to the power of 14, which will become m to the power of 3 plus 14, right? What about the bottom? The bottom, I can times the 3 by 2, which is 6, right? And I can times m to the power of 10 by m to the power of 7. So m to the power of 10 plus 7. You add the power, first index law. Alright, so let's see if we can clean this up a little bit. The top becomes 66, m to the power of 17. The bottom becomes 6 m to the power of 17. Alright, what can we do next? Now we can see this line, which means it's a division. When you see division, we can use, well, let's just check if we can use the second index law. Same base, yes, same base. We can use the second index law. So, we can have 66 divided by 6, which will give me 11. M to the power of 17 divided by m to the power of 17. Right? You can just minus the power. Which becomes 11, and 17 take 17 is 0. Alright, now I want you to think about 11m to the power of 0. What does that equal to? Does it equal to 1? Or does it equal to something else? Let's have a look. This power of 0, does it apply to this whole thing or just the m? It applies to just the m. You don't see any brackets, which means it only applies to this m. So, something is going to become 1, but it's not going to be the whole thing. Only this m to the power of 0 becomes 1. So that becomes 11 times 1. 11 times 1 is just 11. So your answer would be 11. So you can see we've done a great job. All this is just exactly the same as 11. Alright? So, I'm going to put a few questions for you to do. Okay, so I'm going to do 4 more questions with you. This time we're going to step it up even more. We're going to include all 4 index laws into our equations. Let's look at our first question. I've got 12 to the power of 5, then I'm going to raise it to the power of 6. which index law are we going to use? We are going to use the power law, the fourth one. Power of power. Alright, so 12 to the power 5, and then you raise it to the power 6. In that case, we are going to multiply the powers together. 12, 5 times 6, which is 12 to the power of 30. That's how we simplify these. Alright, next question, I'm going to ask you to simplify this whole chunk. Okay, how would you go about doing that? Firstly, before you go any further, what does that mean? Okay, I've got 3 to the power of 2 divided by 5 to the power of 3. I'm raising this whole thing by the power of 3, which means this power of 3 applies to everything inside. Okay? So I'm going to apply this power of 3 to 3 to the power of 2, and I'm going to apply this power of 3 to 5 to the power of 3. Alright? So which index law are we going to use? We are going to use we're going to use the fourth one, right? We are raising a power to a power. So what would happen to the top? The top is going to become 3 to the power of 2. Do I add them? No, we times them. 2 times 3. Right? That's the top. What about the bottom? We're going to times the 3 by 3, right? It's basically saying 5 to the power of 3 raised to the power of 3. 5 to the power of 3 times 3. Okay? So that becomes 3 to the power of 2 times 3 is 6 over 5 to the power of 9. Okay? That's how you do number 2. Let's look at question 3. Again, I'm still asking you to work through these with me, so you're not just watching a video. I want these questions set out in your book, and I want you to step out the steps with me. This time I've got 2b to the power of 5 raised to the power of 2 times 5b to the power of 8 raised to the power of 3. This one is slightly more challenging. So let's just understand what this whole thing is saying. This 2, does it apply to just b to the power of 5? No, it's not. Why not? Because that's the set of brackets, which tells me this 2, this power of 2, applies to everything inside the bracket. So basically what I'm saying is I'm raising 2 to the power of 2, and I'm also raising b to the power of 5 by 2. Similarly, this power of 3 applies not just to this b to the power of 8, it applies to this 5 as well. Alright? So let's have a look how we can write it out. So, as I was saying, this 2 applies to everything inside the bracket, which means that becomes 2 to the power of 2. b, if I'm raising b to the power of 5 by 2, what do I do with the power? You times them, 5 times 2. Right? Then you're multiplying 5 to the power of 3, right? Because 5 is just 5 to the power of 1. 1 times 3 is just 3, so still 5 to the power of 3. And then I've got b, 8 to the power of 8 times 3. Just write that a bit better. Alright, so let's clean this up a bit. So I have 2 to the power of 2 is just 2 times 2. 2 times 2 is 4 times b to the power of 5 times 2 is 10. Multiplying by 5 to the power of 3. 5 to the power of 3 is 5 times 5 times 5. 5 times 5 is 25 times 5, 125. Right? 125. And then times b, or we don't really need to write this times sign, b 24. Right? So one more step. Because 4b to the power of 10 is just 4 times b to the power of 10 times 125 times b to the power of 24. Remember, when we are multiplying, we can change the order. So we can multiply this 4 by 125. If you can't do it in your head, use your calculator. That becomes 500. B to the power 10 times B to the power 24. We have been doing this to death now. The first index law, same base, multiplying, I would add the power. So B, 10 plus 34, and your final answer would be 500. B to the power of, that should be 24. So your answer would be 34. So 10 plus your 24 will give you 34. So that's your final answer. Let's do one last one. Okay. This time I've got something upstairs, I've got something downstairs, and I'm raising a power to a power. Looks complicated, but the math is the same. The concepts are the same. We're not using any new laws. We are still using the 4 index laws. Alright. This 3, does it only apply to this a to the power 5? No. Why not? Because I've got the bracket. The bracket tells me this power 3 applies to everything inside the bracket. Okay? So basically that's what it's saying is 2 is being raised to the power 3. Okay? And this a to the power 5 is being raised to the power of 3. 5 power of power, we times the powers. Over d to the power 2, but then we're raising a power to the power, d2 times 3. Okay? Okay, so let's clean this up. 2 to the power 3 is 2 times 2 times 2, which is 8. A to the power 5 times 3. And the bottom bit is d to the power of 2 times 3 is 6. Can I simplify any further? No, I cannot. Right? Different base, we can't simplify anymore. So your final answer would be 8. A to the power of 15 divided by d to the power of 6. Alright, so just in summary, what you need to know for the first 2-3 weeks would be your 4 index laws. Alright? Make sure you memorize them. I'm not asking you to remember a lot, just 4 laws. Okay? If we are multiplying variables or numbers, same base, in index form, you simply add the powers. If I'm dividing, I would minus the powers. If I'm raising something to the power of 0, that would become 1. And if I'm raising a power by a power, I would multiply the powers together. Okay? Just 4 laws. That's all we're asking. Alright, so pause the video. Keep watching the video. I'm going to put a few questions on the slides for you guys to have a go. Make sure you can nail these 4 index laws. If you've got any questions, contact your teachers or myself. Practice, practice, practice. The only way you can be good at it is by practicing. So make sure you finish all your worksheet questions and your standing task. Finally, I want to talk about some common mistakes. These are the things that I see students are struggling with many times. Let's have a look. If I've got 2 to the power of 3 plus 2 to the power of 4, my question is, does that equal to 2 to the power of 7? Because you think, oh yeah, index law, same base, I can just add the powers. Is that statement true or false? This statement is absolutely false. Why? Because what does the first index law say? Are we adding in the first index law? No, we're not. The first index law tells me a to the power of m times a to the power of n. It's a multiplication. We're not adding. So you cannot simplify this by adding the power. Okay, you can't do that. So this is absolutely false. Second thing I have seen is to make sure you don't make that mistake. Check if they are timesing. You can only use your index law if they are multiplying with the same base, not adding. What about 2 to the power of 3 times, let's say 3 to the power of 4? Does that equal to, 2 times 3 is 6. Then I can add the power of 3 plus 4 is 7. Is that true or is that false? Have a think about it. This is absolutely false again. What is wrong with this statement? What does the first index law tell us? A to the power of n times a to the power of n equals to a to the power of mn. The base have to be the same. We have to have a common base. In this case, the base are not the same. So you absolutely cannot just times the base together and then add the power. It doesn't work that way. You can check it using your calculator. It doesn't work. Please don't make that mistake. One last one is, let's say if I have 3 to the power of a, does that equal to 1? Is that true or is that false? Yeah, a to the power of 0, then you say when we raise something to the power of 0, it's going to become 1. Does that become 1? No, it does not, because this power of 0 only applies to a, not this whole thing. Okay? So what this means is 3a to the power of 0 is the same as 3 times a to the power of 0, right? A to the power of 0 becomes 1, so that still becomes 3 times 1. Actually, that equals to 3 instead of 0. Alright? Okay, so again, I'm going to put a few questions on the board for you to try, on the slide for you to try. Make sure you practice, practice, practice.